Hello everyone and welcome back. My name is Mr. Kovald, and in this video I'm going to be going over how to report an average. So here's a few examples to kind of show you what to do when you're reporting an average value after having multiple measurements of the same kind. So let's look at example number one. So in this example, I have five different measurements of length in centimeters. It doesn't matter what you're measuring. It's just that you're measuring the same thing. Maybe five different people measure the same object, or maybe you measure it five times. But you've got these five different measurements of the same thing. And now you're going to take an average. So you add all of the measurements together, you divide by the total number of measurements, which is five here, and you get this average here. So the question then becomes, am I allowed to report all of these digits? And what is the uncertainty that goes with that measurement or with that reporting of the average? So when you're given a list of digits or a list of measurements, you want to look at what digits stay the same throughout all of the measurements, and that will give you your certain digits. And then the ones that are fluctuating are going to be the ones that are uncertain. Now, there's a caveat to that that I'll talk about in a moment. So right away, you can see that all of the measurements have 6 in the tens place. So this 6 is allowed to be reported. So then the next digit, we have a 1, a 2, a 2, a 2, right? So that seems to be uncertain in the ones place, but we'll hold judgment on that in a moment. But notice here that at the tenths place, you have a 9, a 0, a 1, and a 1. So that is uncertain. So your tenths place is uncertain. And then you look here at the hundredths place, you have a 4, 8, a 1, a 0, a 2. So that's really fluctuating a lot there. So working this way, we can see that our hundredths place is uncertain. There's a lot of fluctuation going on there. And our tenths place is uncertain, not as much fluctuation, but you want to notice something here that the fluctuation in the tenths place is occurring around the 0.9 mark, right? So it's on the basically the edge of a measurement, right, between 61 and 62. So this measurement in the tens place is changing or fluctuating only because the fluctuation in the tenths place here in your first decimal place is right on the line of between 61 and on the line of 62 here. So 61.98 is really close to 62, and 62.01 is really close to 62. So you're really on the edge of 62. So because you have that wiggle room or that fluctuation in the tenths place, that's going to cause some fluctuation in the ones place. So this ones place really is not an uncertainty. It's only because you have this uncertainty in the tenths place, and it's right on the line of your 62. So here, we have the tenths place and the hundredths place being uncertain, and then the ones place is not uncertain. It's actually certain. So don't let the fluctuation in the ones place fool you, because you want to notice that that's only because you have fluctuation in the tenths place, and it's really close to 62 where that edge of 62 is. So that's not uncertain, right? So this 2 here we will keep. And so here we have two uncertain digits. We have two basically estimations. We're not allowed to have more than one uncertain digit. So we have to get rid of one. So we'll get rid of the 3. The last digit here, we get rid of that one because we're not allowed to record more than one uncertain digit. So we would record this as 62.0, and that would be centimeters. And then, of course, we need to remember to add the uncertainty. So since our uncertainty is in the last digit plus or minus 1, and you could see that here, right? So it's going to be, we have a 0 here. So if we subtract 1, that would be 61.9, which we have 61.9, 61.9 there. Or we can add 1, so 62.1. And so you can see here 62.1, 62.0, 62.1. So the 62.0 is within the range of 62.1 and 61.9. So that is acceptable there too. So this is going to be plus or minus 0.1 centimeters for the uncertainty. So if I write that down here so you can see, so that's going to be plus or minus 0.1 centimeters of uncertainty. So this is the way we would record the average of those numbers. All right, what about example problem number 2? So here we have 3 measurements in grams. We're measuring an object 3 times. Maybe 3 different people measure the same object. Maybe I measure it at 3 different times and see the accuracy or precision of my device. And so then I get the average here, so 2.301 grams. And so the question is, am I allowed to record this value, and what is the uncertainty that goes with this? So again, you're going to look at your values here. So you're going to start here, or you could start at this end here, right? So let's start at the end here, the last digit here. So here I have a 2, a 4, and a 2. So there's uncertainty there. And then for the hundredths place, I have a 1, a 9, and I have a 0 there, right? So there's it seems to be uncertainty there. And then here I have a 3, a 2, and a 3, right? So here it seems like there's uncertainty here. 3, a 2, and a 3 there. Now, so how do we decide this? So if we look here, we have 2.302, we have a 3, and we have a 2.9 here and a 3.1 here. So it looks like that this fluctuation in the tenths place is due to the fluctuation in the hundredths place here. So that, because it looks like we're teetering on the edge of 2.3 or 2.29, right? So here we're on the edge of 2.3. So we'll keep the 3 there. And so we have a 0 and a 2. So that's fluctuating. So in these measurements, we have uncertainty in the thousandths place and the hundredths place. And our fluctuation in the tenths place is only because we're on the edge of 0.3. And so fluctuation here is going to cause fluctuation here. And so therefore, we can keep the 2, because notice that the 2 is the same in all of them. So that is definitely certain. The second digit, the tenths place, will accept that is certain, because the fluctuation in the tenths place is only because there's fluctuation in the hundredths, and we're kind of on the edge of 2.3. And you can also see that this digit here fluctuates within 0.1. right? So I have 0. If I take away a 1, if I take away 1, I get 2, 9. If I add 1, I get 3, 1. So I'm a plus or minus 1 in this digit here in my fluctuation. And then so therefore, I can take that as my uncertain digit and drop that one. So because I'm only allowed one uncertain digit, so then I'm going to drop this one and I'm going to keep the 0. So I would report 2.30 grams as my average plus or minus fluctuation in this last digit here, right? So then that would be plus or minus 0.01 grams. So this is the way that I would report my average with the uncertainty. Okay, what about this last problem? So this last problem is going to introduce the question, well, what if I have a difference in the plus or minus? Maybe it's not plus or minus 1, but maybe it's plus in my fluctuation of my reading in the values or in my measurements that I'm getting. Let's say I get plus 2 versus minus 1, right? It's not exactly plus or minus 1 fluctuation. I might have fluctuation greater in one direction than the other with the values I've got. What do I do in that case? So here's an example of that. So you'll notice here that I have for my first digit here, all my measurements agree in the first digit. So I'm going to keep that one. That one is certain. And also you'll notice that they all agree in the second digit, which is in the tenths place. So I have a 9 in all of these. So that is certain. There's no fluctuation in that one. So 5.9 I'm going to keep. Now, notice that I've got fluctuation in the last digit, in the hundredths place. And so I can keep the 6 as an estimate, right? So now I don't have to drop anything here. I can keep it. So I'm going to keep the 6. So for my recording, it's going to be 5.96. Oops, this should be milliliters. So it's going to be 5.6 milliliters that I'm going to keep for my average. And now the question is this plus or minus 1? Can I just write down, oh, it's going to be plus or minus 0.01 milliliters of uncertainty? Normally you can do that, but in this case, you can't assume that because that's not actually the case. So you'll notice here, if you look at the last digit, here I have a 6. So my average is 6 here, right? So this one is right on the average. So it's a 6. This one is 1 below. So this is a minus 1 in that regard. This one is 2 below. So this one's minus 2 in that place here, in the hundredths place. And then you'll notice that this one is 3 above the average. So this is a plus 3 in that place, in the hundredths place. And then this one is 2 above. So we have a 6, we have an 8, this one's 2. So look at the fluctuation in the digits. So this is 0, right? So there's no fluctuation there because it's right on. So this is 0, this is a minus 1, this is 1 less, this is 2 less, this is 3 plus. So then you'll notice that it's not plus or minus 1, right? Because the range is either I'm 2 less than the last digit, or the greatest amount higher is plus 3. So I am 3 above at the greatest, and I'm greatest in the height, and I'm -2 lowest as far as the lowest value goes. So my fluctuation is not plus or minus 1, it's plus 3 and -2. So that's one thing, right? Now, if my fluctuation, let's say instead this was 9.8. Let's say that was 9.82, and then this would be a +2. Then in this case, I have a -2 as the highest fluctuation going up, and then I have a -2 as the highest fluctuation going down. So my range would be actually this would be plus or minus 0.02. So that's the way I would record the average there. But that's if I have the equal numbers up and down. But as I showed before in my other example, so if this was 5.99 and this is a +3, for example, so it's not evenly up and down. So how do I decide whether it's plus or minus 2 or plus or minus 3? Well, the idea is that you always pick the number or the range that gives the largest error, right? So you assume the largest error in your measurement, not the least, right? So since this +3 is giving you the largest error because it differs by 3 in that place rather than 2, then you're going to take the largest error in that case. So in this case, we would go with the 3. So it's going to be plus or minus 3, right? Because if we took more measurements, it could be the case that I could get a measurement that was going to be a -3. So maybe I might get a measurement that would be 5.93, and then therefore it would be -3. So maybe I just didn't take enough measurements, but the very fact that I got a measurement that was 3 higher in that place tells me that that is at the most, that's the most error that we got based on the average. So remember, we're basing this on the average here and based on the last digit that we're accepting as the estimated digit. So I hope this was helpful. If you enjoyed this video, if you got a lot from this video, and if you learned anything in any way, shape, or form, please by all means like the video, share the video with your friends, hit that like button, and also make sure you subscribe to my channel, hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think, and I would love to hear from you. Thanks for joining me, and have a great day.